Okay, we're going to try and find the cubic equation given this picture and given this formula. We're told that we've got a cubic equation here and that it's f of x equals x cubed plus ax squared plus bx minus 2. Two unknowns here. We're supposed to find a and b. Well, let's quickly look at this thing here and go, hey, I see that this is going up like that, so that fits with this being a 1 here. The shape fits with it. If x is 0, that point there must be minus 2. But there are two things that we're given here, namely this point right here. We've got a point that works in this function here, and we know this is a turning point. They tell us it's a turning point. So when the gradient is 0, if we take the derivative, whatever makes that 0 is at minus 1, right? So minus 1 makes the gradient 0, the derivative 0. We're going to set up two equations in A and B, and we're going to solve that system of equations. That's what we do. So the first thing we do is we take minus 1, and we know that minus 1 for x and gives you minus 1 for y. So we put minus 1 in for where it's said x cubed and ax squared. We just replace x with minus 1. We replace the f of x with minus 1. That's y is minus 1. And then we just simplify it. We get minus 1 here. You'll get minus 1 squared is 1, so you get a. That's minus b. Minus 1 times positive b. You've got a minus 2 there. Minus 1 minus 2 is minus 3, but we add 3 to both sides. We'll get a minus b equals 2. You can go through it carefully yourself and solve it yourself, try it yourself, and you get your first equation in A and B. Hey, but we know something else. We know that this turning point, if x is minus 1, the derivative f prime of x equals 0. F prime at negative 1 is equal to 0 because it's a turning point. Well, we just take the derivative just the way we did. We've got x cubed, so it turns into 3x squared. We've got ax squared, so it turns into 2ax, and we've got bx, so it turns into b. Just take the derivative and then make it equal to 0. And instead of x, put in minus 1 because the derivative is 0 when x is equal to minus 1. And then we just work it out. That's going to be 3. That's going to be minus 2. That's b. If we move the 2a and the b over there, we'll get 2a minus b equals 3. And that's your second equation. Now, all we do, you go through this carefully yourself, but that's all it is. Okay, we've used the derivative, and we use the fact that minus 1 and minus 1 work in the function to come up with two equations in A and B. We got this one using the derivative, this one just stuffing in minus 1 and minus 1 into the original equation. Now, if you remember how to solve a system of equations, if we subtract these two, it's called the linear method. 2a minus a is a, minus b minus minus b is minus b plus b, and 3 minus 2 is 1. We've just got one of the answers, a equals 1. And all we do is put 1 here and put 1 in here. Then if we move the b over to this side and subtract 2, 1 minus 2 is negative 1. So b will equal minus 1. We let a equal 1, and then we solve. The b goes over. 1 minus 2 is negative 1. So a is 1, b is minus 1. And we've done the whole thing just based on two ideas. Taking the point, putting it into the negative 1, putting it into the original function and getting an equation in A and B. Then taking the derivative and putting minus 1 in to get 0 out. And that's the whole story. That's how it works. And that's the end of this